I assume yes. Can you guys hear me?
Yeah.
Okay.
Yes.
Okay. So, yeah. Thank you, Danny and team, for sharing so many valuable knowledge. Okay, it's my turn now, and well, first I have to say my marks are generally very generous. I give 99 out of 100 for Group 4, but that doesn't mean Group 4 has achieved the industry standard. It's just an encouragement. Okay, so the code is well written and organized, and the team has considered a lot of important topics like oversampling, interaction, multi-collinearity, etc. It would be even better if the team can show individual impact of each chosen factor. I'll explain that later. Okay, so first let's have a look at the code. Well, I don't have much feedback for the code. The code is well written. Only some 2 comments. The first comment is that I noticed that the team used the package dplyr. Well, dplyr is one of the most popular R packages for data manipulation. And the other one is data table. Well, they have pros and cons. If we use dplyr, we have greater compatibility because a lot of packages are written under the the big package tidyverse, right? Like in tidyverse, we have loop-redate, string R, ggplot, dplyr. If you use dplyr, that will give you better compatibility. But then I was told, and that is also what I found myself, that sometimes data table is much better because the basic idea of data table is that find the location you want to change and then make the change at a place at that location. But other R packages like make a copy of the original data, make the change, and then replace the original data. So that takes time. When you handle a very big data set, maybe data table is better. For example, I noticed you use read.csv to read the CSV table. But when the CSV table is very long, I mean, the number of rows is very big, then sometimes if you use fread, okay, under the data table package, that'll be much faster. Yeah, that's one of the 2 feedbacks. The other one is personal preference. Maybe you can align your code better. For example, you can do something like this. You can put all the equal sign in the same vertical line, and then also the components of your if-else function. Sorry. Well, I will not do it. I guess you know the idea, right? If you align your code perfectly, then it takes the minimum effort to pick up what the coder is really thinking about. Yeah. So other than the 2 feedback I gave, I think it's pretty good. Yeah. Okay. So I have drawn some slides. Maybe I should. Can you guys see the picture? Okay. I'll check to the side. There are 6 comments in total I want to give. The first one is I want to introduce emblem style AVE graph. Okay, emblem is a WTW software, various targets in WTW. It's very useful and powerful tool in the actuarial industry. And before joining IAG, I worked in Allianz for 2 years, and we use emblem in Allianz a lot. But then IAG doesn't like emblem. But I think the idea, the idea of the emblem is very helpful to streamline, or sorry, to make your thoughts more clear and make your communication to stakeholders much easier. Yeah. So as you can see, it's a graph with two vertical axes. So the first y-axis is exposure weights, which is the bars here. Like the sum of the weights for level A, and sum of weights for level B, level C. Yeah. And then the diamond solid line here is the predicted, like your model prediction. And then the solid dot and the dashed line here is the actual. And then the double line here is the error band, like the upper band, lower band. You can do some sort of a distribution, for example, normal distribution. And then you can compare the actual and expected within this error band. So generally, you should put more trust on high exposure level. For example, for level C, the exposure is very low. And as you can see, the gap between the predicted and the actual is very big. Generally, it's not a problem because it's still within the error band. Yeah. And then you can apply this kind of graph to like each individual rating factor or some time series. For example, if you want to see the actual was expected across the years or quarter, yeah. Or you can do this, or you can apply this graph to deciles or maybe percentiles if your data set is big enough. Yeah. Well, the second comment is that maybe it's better to do some sort of residue plots. Yeah. You can Google deviance residue or log residue, or what kind of, or any kind of residue. But the basic idea is that you want to see the distribution of the residue after you fit the model. Yeah. For example, there are two ways to show the residues. The first one is you put row ID to the x-axis, and then if your residue distribute like a rectangular, then generally it's good. If you see some weird trend like this, then you miss some important features. And if you put log of p in the horizontal axis, then if you are if all the doors cluster around one blob, then it's good. If you see some weird patterns like this figure 8 here, then it's very bad. Okay, the third one is maybe we can show. Okay, I'll check it to the other side. Maybe you can show the factor importance graphically. I noticed you have pasted some outputs of the R console at the end of your paper, but probably it's not a good practice. What you can do is like you extract the coefficient table from your model object, and then sort the coefficient, sort the factors by the size of the coefficients. Like for example, a factor 1, factor 2, factor 3, so on and so forth. And then on the, well, this is the 0 line. And then on the right-hand side is the positive coefficients. And then the other side is the negative coefficients. And then you can see the most significant positive contributor of your model and most significant of the negative contributor of your model. And also some factors that are not very important. Yeah. And the fifth comment is you can Google the idea of spline. Well, I'm not saying that it's wrong to not use spline in your model. I'm just saying that in practice, it's a very popular and important idea when you work as an actuary or an actuarial analyst. For example, we generally use spline for some issue, like the most significant contributor of your model, of your pricing model. Yeah. Well, if you apply the idea of spline, you have to think about how complex your model is. For example, you can cut your cut the entire range of data into 3 parts. Like for example, the first part you assume is the linear relationship, and then the middle part is like you assume the second order multinomial function, and then the final part you assume constant function. Well, you can do this, but you face the risk of overfitting. Well, in contrast, you can do the right-hand side as well. Like you assume constant in the first part, and then first order in the middle, and a constant in the end. But you face the risk of under modeling. So it's really a trade-off. Yeah. Okay, the final comment. I noticed that in the end, the team chose to use GLM, but GBM is equally important because in practice, GBM is more versatile, it's more flexible. I encourage you guys to do some research on GBM or XGBoost. Well, my recommended topic is to understand SHAP. Well, I have two recommendations. The first one is you should know the idea of a subrogate model. I will not explain here. Google it yourself. And the second recommendation is that try to create a following graphs without using packages. The first one is SHAP importance. It looks like this. Well, this graph is very similar to this graph, except it only has positive value because it's absolute importance. Yeah. And then the second one is the SHAP tree graph. It looks like this. Try to figure out the idea behind the SHAP tree graph and try to think of some ways to explain it to our teammate, to someone beside you, yeah, because it's a very hard topic to explain, especially to the non-tech people. And the final topic is individual SHAP. Well, this graph is pretty much the same graph here, except that one is for GBM and this one is for GLM. Okay, and then I have a bonus question, which is how to create individual SHAP graph for a continuous variable. I mean, for categorical variables, we have different levels, and then we can summarize the mean of the, SHAP score. And then you can see the relativity for each level. But then for the continuous variable, if we take the mean of the SHAP score, it's just a one data point. But for example, for some insurer, you want to see the monotonic increasing trend, then the question is how to create an individual SHAP graph for continuous variable. Yeah. Okay, maybe let's have a look at the report. Okay, I think I've covered most of the things I want to say in the picture, the thing I draw. But I just want to make it more specific. For example, this one, Appendix 1A, probably it's better to put them into bar charts because it's more intuitive. Yeah. And probably it's a bad idea to paste a large chunk of console output here. Maybe it's better to make it more visual. Yeah. Well, this graph is good. Yeah. It's like PP, FP, Lorentz curve. Yeah. For this parts, for this graph, maybe you can replace it with the so-called emblem style. The emblem style graph. I mean, like actual versus expected, overlaid with exposure and error band. Yeah. Yeah, that's all I want to say. So, any questions? Hello?
Hello?
Hey.
Hi, I have a question. My name is Cayman from Group 4. Thanks for AWS and thanks for robust advice. I'm just wondering, as you mentioned, for the factor importance graph, because we use random forest to select the classifier and like obtaining the importance of each level. So do we have to like use the factor importance graph to in this project, like because I think random forests for random forests I can obtain the importance of each variable as well.
Like the gain matrix, right?
Yes.
Yeah. Well, I mean, the general principle is that if you can put something visual, then make it visual, because it's harder for the brain to absorb numeric information. But looking at graph is very quick, right? Yeah. I mean, in terms of the model training, research, some initial evaluation, I'm pretty happy with your report. What I really want you guys to improve is how to enhance the explainability of your model, like make your model easier to understand for stakeholders. You know, in practice, communication is very important. Yeah.
All right, thank you. Okay, and I got another question. Like, I'm wondering if it's in the industry, like how long a data analyst will be given to work on a similar project?
That depends.
I'm just curious about it.
It depends on the importance and the capacity of your project, but generally 2 or 3 weeks for more projects and maybe a month for larger projects. Yeah, but you know, a model training part is very easy. You have to spend a lot of time in model evaluation, model monitoring, and also enhance the explainability. Yeah, sometimes you build a very good model, but then your stakeholder, for example, the product team told you that no, we can't use it. And sometimes, for example, you use Tania in your model, and then the compliance team said, no, Royal Commission will, you know. So there's some practical limitations, and it's an iterative back and forth process. And the exact time you spend on the project depends on the situation. Yeah.
All right, thank you.
All right.
And also, one more question. So, do you have any advice regarding to the recommendation part?
The recommendation part. To be honest, I just flip through that part because practice we don't. Well, I wouldn't say it's not important, but probably for the beginners, I mean the junior analyst, your first year will be dealing with data and model training, and it's probably not your place to make some recommendations. And sometimes your recommendation has to fit in the big picture of your team. And sometimes if you want to make some recommendations, if it is internally, then it's okay. But if it's a cross-team recommendation, you probably want to ask your manager to do that job, to make sure that there's only one voice speaking for your team. Yeah.
Yep, thank you. That's all my question.
Oh, nice. Anything else? Then I will pass it back to the host.
Okay, great. Thank you, Robert.
Nice.